welcome to more algebra. Today we're working with our first part of exponents. We're going to start with some basic rules and also learn how to multiply. Here we go, take out those notes and we're off and running. So first you need to know two basic rules. One is the zero exponent property. All that means is if you have a zero for your exponent, your answer is 1. Next we have the negative exponent property. This one gets a little bit trickier for people, but it's not too bad. If you have a negative exponent, you are going to think of what I like to call the elevator. So if you are at our school, we have 2 stories. There's an elevator and you can get in on the top or the bottom. If you choose to, let's say you're on the 2nd floor and you press the little magic button, it lights up, right? So it's glowing. And the button lights up, you get in the elevator, you press the button, it lights up for 1. Your only option is to go down. If you're on the bottom floor and you press the magic button, your only option is to go up. So the top number goes to the bottom number goes to the top if you have a negative exponent. Now, what happens to that light once you make it to your floor? Well, the light goes off. So the same thing here, your negative exponent, that negative goes off. It disappears. So for example, if I have x to the negative 3, this would be the same as 1 over x to the positive 3, because you took this guy and you moved him. Now, this didn't have a denominator, so we could always put a 1 there. So that guy moved to the bottom. Let's try some out. So this first one, I've got negative 3 all to the negative 2 power. Because the negative 3 is in parentheses, I'm going to leave it in parentheses. And remember, if there is no denominator, you can always put a 1 there. So that guy is going to move down. So this gives me 1 over negative 3 to the 2nd power. Now that 1 did not actually move to the top. Actually, when I did this, I should have just left it like that. So I just moved that negative 3 to the 2nd down. And if I wanted to put a 1 out here, I could, but there's really no reason to. The problem is, my fraction here is topless, and I'm not allowed to show you a topless fraction, so you always put a 1 there. Next, we have negative 3 all to the 2nd power. So this is negative 3 times negative 3. Negative 3 times negative 3, 9. Boom, we're done. That's it. Alright, let's try this one. This is the same as 1 over negative 2 to the 3rd power. Again, that negative here disappears. This is negative 2 times negative 2 times negative 2. Well, negative 2 times negative 2 is positive 4. Positive 4 times negative 2 is negative 8. So this becomes 1 over negative 8. For the next one, anything to the 0 power, remember, is 1, so that's all there is to that. Over here, this 7 has no exponent. I know it looks like it's attached to that x, but remember 7x is the same as 7 times x. So you're thinking this like they're 2 separate things. Even though it's the same term, there's a difference between the 7 and the x. So 7 has a 1 for the exponent. Remember, whenever there is no exponent, you are always going to put 1 there. Even though it seems silly, I'm telling you, if you put the 1 there, this will make your life so much easier, this unit. Do you trust me? Do you? I'm hoping you do. So, this guy, that 7 to the 1st power, he does not like to move it because he has 1 for his exponent. It's positive. This x, though, he has a negative exponent, so he likes to move it. He goes down to the bottom. So in your final answer, that was a positive 1. You can leave it off here in the final answer. That's fine. I don't care. But this x to the negative 2 goes down to the bottom. But remember, you don't write negative 2. You write positive, because once he goes down to his correct floor, he's all finished. No more negative to worry about. Alright, this next one, same deal. We're going to put a 1 for that exponent. These guys already have exponents. Who likes to move it? Well, x does, and so does y. You'll notice whenever anybody likes to move it, I always put a box there. You should also put a box around it and draw the arrows. Again, Even though this may seem silly to you, it's going to save you a lot of mistakes in the long run, and you'll thank me. All right, that's 7 to the first power. He's going to stay where he is because his exponent was positive. That y squared, though, he goes to the top. And the x squared, he's going to go to the bottom. Exponents become positive, and we're all finished. Okay, let's move on to this one. You go ahead, try these on your own. Hit pause, try them, and then come back. All right, it looks like you're all finished. So here we go. He likes to move it, so does he. They're going down. So that x to the 5th stays on the top, that 4 to the -2, and the y to the -7 is on the bottom. The only final step is to go ahead and multiply out that 4. So, oh my goodness, did I really put a negative there? Just seeing if you'd catch that. Hopefully you put a +7. 4 to the -2, oh, I left that negative also, just to mess with you. So you did have positives for both of those, of course, because you changed them both to the bottom. So this is the same thing as 4 squared. 4 squared is 16. So that's all there is to that one. Remember again, whenever you change a negative exponent, whenever you move it, it's going to become positive. Hope you caught that. Good job. All right, this one, negative exponent. He goes down, negative exponent going down also. So the z to the 4th power goes on the top, 5 cubed, and y to the 9th on the bottom. Hey, did I forget the x? No, I actually didn't. This is x to the 0 power. Remember, anything to the 0 power is 1. I could have just left it off or put the 1 there. That's okay. Final step, you know that 1z to the 4th is just z to the 4th, so I'll leave that alone. 5 cubed, this is not 15, it's actually 5 times 5 times 5, which is 125. And that's your final answer. This one is also similar. Go ahead, try this one out. I'll be back in a minute after you try it. Okay, it looks like you're finished. So let's go. Who likes to move it? Well, he does. And so does he. They're both going down in the elevator. So I've got y to the 9th power, and then -3 all squared, +2 for the exponent, and x to the +6. My final step is to go ahead and multiply out that 3, so -3 times -3 is 9. And we're finished with that one. Now, this one, hopefully you didn't do much work because you saw that this whole thing was to the 0 power. Remember, anything to the 0 power is 1. Did I trick you? Next, let's go ahead and substitute. Instead of a, we're going to put 2. I just put that b equals -3 there to mess with you because there's no actual b's here, so you're not going to even use it. So wherever I see an a, I'm going to write 2, and I'm going to put it in parentheses. So let's just copy that, and that, and here, same thing. So you're noticing all I'm doing is just copying everything just like that. Every time I saw an A, I put a 2. Alright, now this 4 is to the 1st power. So he does not like to move it. But this guy does. So 4 to the 1st power stays on top. 2 to the -2 power becomes 2 squared on the bottom. You know that 2 squared is 4. And you can divide those to get 1. Next over here, knowing our order of operations, we're going to do 4 times 2 first. So 4 times 2 is 8. Next I have 8 to the -2 power, so that -2 means I'm putting him on the bottom. Again, I should probably, out of good habit, keep those parentheses. Next, 8 squared gives me 64, and I'm all finished with that one. Over here, remember, order of operations tells you do exponents first. So that 2 squared becomes a 4. -4 times 4 gives me -16. Notice there was no negative exponent. A lot of people would take that guy and move him down to the bottom. Next over here, order of operations tells me let's go ahead and multiply those first. That gives me negative 8. Negative 8 all squared is the same as negative 8 times negative 8, which is 64. 64 is your final answer. So notice right now that even though all of these questions look really similar, the answers look nothing alike. They're very, very different. So be very, very careful with your positive negative signs and with your flipperoos with the exponents. Next half, we're going to do multiplication properties. Multiplication properties, this just means when I have the same base is the physically big looking number there. So when I have the same base, I'm going to add the exponents when those two bases have a times sign in between. So for example, if I have 4 cubed times 4 squared, that's a 4, that's a 4, so my final answer is going to have a 4 in it, and I'm going to add those two exponents to get 5. Don't multiply the exponents. I always tell people that those exponents remind me of a friend of mine who's really kind of slow. You might have a friend like that. Don't point at them if they're in the room, but exponents are a little slow. So even though the bases are multiplying, the exponents are a little behind, so all they can do is add. So here, 7, 7, 7, they're all 7s, so I copy the 7. 3 plus negative 8 is negative 5, negative 5 plus negative 6, negative 11. Over here, 3, 3, 3, so I'm going to put 3. 11 minus 20 is negative 9, negative 9 minus 7, negative 16. Okay, moving on. Remember, if we have no exponent, we're always going to put a 1. So that's your very first step. Next step, let's go ahead and add those exponents. This gives me 3, and then you keep the same base. Now this, remember this is a times sign, so really it's separating those. So I'm doing 7 plus negative 4. That 5 to the first power is just getting copied down. So 7 plus negative 4, 3. Done. That's all there is to that one. This one, putting these 1s here will really save you, because a lot of people, if they didn't put the 1 there, they would have said it was 8x to the third power, but we know that 1 plus 3 is actually 4. Okay, now for these look complicated, but they're not so much. So I have a 3 and a 4. All of these are multiplied, really, so if I wanted to put times signs here, I could. So if I want to, with multiplication, I can write multiplication in any order. So if I want to rewrite this in a different order, I can. And I do, so I will. 3 and 4. I'm putting the big old numbers together. Then I have x squared and x to the third. I'm going to put those together. So 3 by 4 gives me 12. X squared times x to the third. The x's stayed the same, and I'm going to add those exponents to give me 5. And I'm finished with that one. Alright, do you think you can do this? Sure you can. Go ahead, hit pause, do this one, and then come back. Alright, it looks like you've got this. So here we go. 3, 5, 2, they all go together. X to the fourth, x to the fifth, and y squared. 3 by 5 by 2, that gives me 30. X to the fourth by x to the fifth, that's x to the ninth. Y squared did not get put in with that because that's a different base. Just like 3, 5, and 2 don't somehow smash into the x to the ninth, they're all just multiplied together just like that. So the 2 and the 9, they don't go together to make 11. They're different variables. Alright, I think you're ready for this. Go ahead, give this one a shot. Come back when you're ready. Alright, hopefully you rewrote this like this. 2 by 3 by a to the fourth. You remembered to put that 1 there. Good job. A to the first, b to the negative 8, and b to the fifth. So this gives me 6a to the fifth, b to the negative third. Ooh, look, we have a negative exponent. Now, one important thing to remember is when you're doing these problems, if you have a negative exponent in your final answer, you may as well just mark it wrong for me, because you will never have a negative exponent in your final answer. Always, always change it to a positive. So the way to do that is remember that he likes to move it, so he's going down. That's 6, that's a positive 1 exponent, so we're going to leave it as 6. So I have 6a to the 5th over b cubed. And then I'm finished. With this one, I'm going to reorder it. So I've got 3, 4, a to the negative 9, a to the negative 3, b to the negative 6, and b to the 5th. 3 by 4 gives me 12. Negative 9 plus negative 3 is negative 12. And then negative 6 plus 5 is negative 1. Finally, who likes to move it? Well, that 12 does not, because he has a positive exponent. But you know who does? A and b. So 12 stays on top, a to the positive 12th on the bottom, and b to the negative first, or to the positive first on the bottom also. That negative 1 became a positive 1. If you want to put the 1 there, that's great. Finally, let's talk about area. To find the area of any figure, you're going to multiply the length times the width. So we're just going to take 5x times 3x squared plus x. In order to do that, you remember your friend distribution. You're going to multiply those and multiply those. So it's the same as 5x times 3x squared. Alright, we know how to do that because we just did a problem just like it. And then over here, I'm going to put a plus sign because that was plus. And then I have 5x times 1x. If I want to put a 1 there, I can. We're going to put 1s there for our exponents of the x's. Alright, let's just worry about this red part first. So I've got 5 and 3 that go together. And I've got x to the first power and x to the second power all together. So 5 times 3 gives me 15. X times x squared is x to the third. Then I put a plus sign here. Over here I'm going to rearrange, so I've got 5 by 1, and then x to the first by x to the first. 5 times 1 is 5, x times x is x squared. And that's all there was to that one. Similarly, we're going to do the area of a triangle. Area of a triangle is 1/2 base times height. And we can reorder these any way we wish. So we're going to put the 1/2, the 4, and the 5 all together. We're going to put the x to the 5th and the x together. Now remember, when we don't have an exponent, we can always put a 1. This will really help you, so I'm hoping you're doing it. Finally, I have 1/2 times 4 times 5. Half of 4 is 2. 2 times 5 is 10. X to the 5th times x to the 1st is x to the 6th power. And that's all there is to that one. Alright, we're finished with new material, but before we go, I just want to say make sure you're doing that homework. Try every problem, see how you did, compare it to your answers, and see how it went. Alright, thank you so much for paying attention, everybody. I hope you have a wonderful day. I'll see you again tomorrow.